Web2GoTech is out here asking the big questions. What if your chips were smarter, your data was cleaner, and your strategy actually held together? Valerine G has some thoughts.
This episode covers two territories: how specialized AI chips are reshaping industrial and commercial operations, and why data preparation and strategy sit at the foundation of any of that working at all.
Let's start with the chips.
The central claim here is that purpose-built AI chips are not incremental upgrades. They change what marketing, sales, and manufacturing systems can actually do in real time.
The T9 AI chips post puts it plainly. With T9 AI chips, data flows faster, personalization gets sharper, and automation becomes intuitive.
What that means in practice is that marketing teams are no longer waiting hours for actionable insights. Behavioral data, cart activity, and engagement signals are processed at the edge in milliseconds and fed directly into campaign decisions.
So the lag between a customer doing something and a business responding to it basically collapses. That is a meaningful shift in how sales cycles work.
The post maps it out concretely. Before T9 chips, personalization was demographic targeting, and CRM updates were manual. After, you get behavioral and contextual targeting alongside automated workflows. Campaign optimization moves from weekly adjustments to real-time testing.
And on the manufacturing side, the B4 AI chips post makes a parallel argument for the factory floor, which, if anything, has even less tolerance for latency than a marketing dashboard.
Right. B4 class chips are engineered for real-time inference, massive parallel computation, and ultra-low latency control loops. The post is direct about the stakes. AI-accelerated hardware is no longer optional. It's the backbone of next-generation precision manufacturing.
Milliseconds matter differently when you are cutting aerospace components than when you are A/B testing a subject line. But the underlying logic is the same chip doing the same kind of work.
The B4 post details how that plays out across predictive maintenance, robotic motion control, and automated quality inspection, environments where every micron of deviation has downstream consequences. The chips run sensor fusion and predictive modeling simultaneously, catching tool degradation or thermal drift before a defect occurs.
Two very different industries, one architectural argument. Specialized silicon closes the gap between data and decision.
And that gap only stays closed if the underlying data is worth trusting, which is exactly where the next territory begins. Before any chip or model can act on data, someone has to collect, clean, and structure it. And the post on data exploration and preparation lays out why that foundation is harder to build than it looks.
The conclusion there is worth quoting directly. The quality of the output always depends on the quality of the input.
That single line is the whole argument. Exploration, cleaning, transformation, storage, every step in the preparation pipeline exists to protect that output quality. Faulty input produces misleading insights, and misleading insights carry real business and legal consequences.
The strategic planning post extends this into backup architecture because data you cannot recover or trust does not support decisions, no matter how good your visualization tools are.
Exactly. Hybrid and full backup strategies are framed there not as IT housekeeping, but as a direct input to analytics quality and business continuity. The data has to be protected and accessible before it can drive anything.
Smarter chips, cleaner data, sounder strategy. It is a tidy stack, and the argument holds together across all of it.
Next time, we will see what else is building on that foundation.